I'm Mark Nyholmem, staff engineer and mechanical R&D manager for AMSOIL, and this is our mech lab. Let's give you a little sneak peek of what this mechanical lab does for AMSOIL. It is a piece of our validation process for all of the products that we come to market. If I was just a blending facility, I wouldn't need a mechanical lab to validate my products. I take fully formulated versions from chemistry partners, I mix them together, and I sell them to consumers. But that's not what we do here. We take it from the chemical level, we break it down, we make really good formulas, and then we need a place to validate them. And then we take it down here in the mechanical lab and put those formulas to work in actual applications, whether it's engines, transmissions, hydrostats, compressors. That's what we do here. So there's a difference between those that just blend and those that fully engineer their products. Every project that we work on here in the mechanical lab typically starts with an application out in the market. There's a problem that we identify, or some customer has a need that is not currently being met by another lubricant. We start with product requirements. We need a way to gauge success. So we bookend what this product should look like in the end. Then we go to work in our chemical lab. We start mixing formulations together, and we use industry standard tests to get us successful on the bench level. But we don't stop there. We need to validate that product before we commercialize it. And that's where our mechanical lab is a huge asset to AMSOIL. We put those formulations into real engines. We beat them up. We put them through really long tests, insane temperatures, really heavy loads, all so that we can take all that data and see whether we've achieved success. Now that you have a firm grasp of our validation process here in the mechanical lab, let's go take a look at the capabilities of each of our cells. Our mechanical lab has 3 dyno cells. In cell 1, we have a superflow water break, where we'll put anything from a small snowmobile engine all the way up to a 1,000 horsepower elephant engine. Dyno cell 2, a little more flexibility here, where we'll run small engines on fixed test stands for hundreds of hours. We'll run weed whips and blowers, making noise for hundreds of hours. And we have a Midwest eddy current, which is super accurate for long periods of time, where we'll run small V6 or V8 engines, or we'll adapt a different test stand and run hydrostats from zero-turn lawnmowers. In our last cell, dyno cell 3, we have our Superflow roller dyno, where we'll put motorcycles, dirt bikes, street bikes, side-by-sides, and we'll take field data that we collect from the road, in the woods, doing hill climbs, and we'll duplicate it on the dyno. And then we'll turn up the knob a little bit to reach what we consider severe testing. Very rarely do we make decisions around here based on subjectivity. We are in the business of measuring things. That's how we learn, that's how we formulate, that's how we engineer, and that's how we make products for you to sell to your customers. So how do we measure stuff? We use the tools built into our dynos, which is measuring horsepower and RPM and temperatures. We use data acquisition systems to measure a lot of some of those same things if they're not really integrated to my dyno. And then what we do is we graphically look at them, and we make sure that if we're measuring power or torque or RPM, when we set up a dyno profile, we want to make sure that that engine is operating that profile every single time and it's not deviating. If it's a deviation from that, then something's happening in the engine that we need to know about. So we take these measurements to make sure that our test is valid. And at the end of this analysis, we shut down the engine, or whatever it might be on test at time, and then we tear it apart. And that's where the true physical measurements come in. So we use measuring tools, and what we're doing is we're comparing before to after. Let's dive a little deeper into some of the documentation techniques we use in the mechanical lab. We use a high precision camera to document the before and after condition of the parts under test. And what we're looking for is deposits and wear. In this area of the mechanical lab is where we tear everything down. This is where we physically measure the before and the after condition of everything that we've just taken off of test. So for example, we have a two-stroke blower here, and we're gonna measure the difference between the wear that you might find in the cylinder. We're gonna measure the wrist pin. You look at a hydrostat transmission from a zero-turn mower, we're gonna look at the pistons and the swash plate that builds pressure and propels that thing forward. We're gonna look at the deposits that form inside that case. You look at the set of cylinders from a snow machine, we're gonna pay particular attention to the bores, the cylinders, and we're gonna measure that profile difference from before and after. You look at a set of bearings on the other side of the table, from the crank and the rods, we want a before and after measurement of the wear to those bearings. The measurements that we take here are of the utmost importance to AMSOIL. We use these measurements to make decisions on new products coming to the market or new technologies that we're investigating to put into the current products that we have out in the market today. We put a lot of importance on this to help you be successful. So hopefully you can make it up here someday and see it yourself. But until then, we got to get back to work on the top secret projects that I can't share with you. Thanks for coming.